Last class we learned about acceleration, constant acceleration. And we learned that when things are moving in a straight line, we can use these equations. Now, these are the way the equations, here's a typo, here's the way the equations appear in the textbook. But when I want to memorize them, which I need to do, this is an easier way to do it because most of the time they're going to tell us the elapsed time, delta t. So if I remember them without the t's, it makes it a lot easier. How do I know when to use each equation? Again, each equation has different variables. So this one has x, vi, vf, and t. This one has x, vi, t, and a. This one has vf, vi, a, and x. And then this one has vf, vi, a, and t. So when we write down what we're given, and we write down what we want to find, and we look at the four variables, it's very easy to figure out which one to do. Now, the interesting thing about your textbook is the practice problems, which is what we do for homework, they're arranged according to a certain equation. So like practice C all use the same equation. Practice D all use the same equation. Not always, but most of the time. And then in your textbook, there's an example right before the practice problems in the book. So these are always grouped together. Now, when you take a test, you're not going to know, oh, these all use the same equation. So the test, you have to figure out which equation you're going to use in which situation. All right, so let's start the homework together. And we're going to start with, we're doing C. So we'll do C1. It says a car accelerates uniformly from rest. So I'm going to write my given, and I'm going to write what I want to find for each problem. Now in physics, we read words, and those words have actually sometimes a numerical meaning. So when it says from rest, that's very, very important. So from rest means that the initial velocity is 0. That's what from rest means. To a speed of 6.6 meters per second. Well, the word to means that's my final velocity. In 6.5 seconds. Now that's 6.5 seconds. That's actually the delta t, the elapsed time, because they don't tell you it starts at one time and ends at another. So that's t. And most of the time when they say in, that's the elapsed time. Then it says find the distance the car travels. So we want to find x. And that's it. How do I know where to begin? Well, the first thing I'm going to do is I'm going to say, what are the four variables that I'm dealing with here? Well, I have vi, I have vf, I have t, and I want to find x. Those are my four variables. So now I'm going to say to myself, do I have an equation that has those four variables? So if I look at my list of equations over here, I see that's the first one. So when you're taking a test, what you would do is after you memorize these four equations for our test on this chapter, on the back of your FRQ paper, you write down the four equations right away. Okay? But you're going to see as we do the homework over and over again, and you're using the same four, you'll just remember them. So first we write our basic equation. X is equal to 1/2 VI plus VF times T. Now we substitute in our values. 0 plus 6.6 times the time, which is 6.5 seconds. So now when I do it on my calculator, and remember, this is the calculator you're going to be using on the test, so 6.5 times 6.6 equals, divided by 2 equals, so it says 21.45. Now, when I'm going to be doing it with correct significant figures, this has 2 and this has 2, and my final answer is going to be 21 meters. I probably rounded too much. And then I want to check my units. So we said the great thing about physics is we have a foolproof way to check our work every single time. So this, and I forgot to write it in here, this is a meter per second. That's the unit here. times a second. So if I look at my units, this cancels with that, and I end up with meters. Is that the correct unit for displacement? Yes, it is. So I always have a way to check my work in physics. All right, since number 4 is a little bit, it has conversions in it, because 2 and 3 are easy, let's do number 4 together. So number 4 says a car enters the freeway with a speed of 6.4 meters per second. So VI is equal to 6.4 meters per second, and it accelerates uniformly for 3.2 kilometers. Well, that's not the acceleration. If you're not sure what something is, look at the unit. So kilometers is displacement. So this is equal to 3.2 kilometers. Now, right away, before I go on, you see how this and this are not the same units? So I wouldn't be able to cancel, so I know I actually have to do that conversion. So I'm going to say to myself, I'll do that conversion right away. In 3.5 minutes, so T is equal to 3.5 minutes. Again, this minute is not the same as a second, so I'm probably going to have to convert that as well. How fast in meters per second? So I want to find how fast, I want to find a velocity, is the car moving after this time, so that's going to be the final velocity. So because this has to be in meters per second, instead of trying to do it all in the problem, which sometimes the textbook does, I think it's best to do the conversions first to get them out of the way. So let's do this one first. If I have 3.2 kilometers, remember kilometers, it's like it's in the numerator. And if something's in the numerator, to get rid of it, I put it in the denominator. And I want to go from kilometers to meters, and there's 1,000 meters in 1 kilometer. So these kilometers cancel, so I end up with meters. So 3.2 times 1,000 would be, I can do that in my head, 3,200. Okay, now I'm going to convert the minutes. So I have 3.5 minutes. And again, pretend this is, put it over 1 so you know it's in the numerator and you don't make a mistake with your conversion. I have minutes in the numerator. If I want to get rid of something in the numerator, I put in the denominator. And I want to go from minutes to seconds, and I know there's 60 seconds in 1 minute. This minute cancels with that. The one in the numerator cancels with the one in the denominator, so I end up with seconds, which is what I want. And 3.5 times 60 ends up to be 210 seconds. Now, let me do my physics. So I have VF, I have X, I have T, and I want to find VF. So which equation has it? Well, like I said, the practice problems in the book, each letter, they all use the same equation. So it's going to be the same one we did before. So X is equal to 1/2 VI plus VF times T. Do not substitute in your values. One thing we always have to do in this class, and this way you'll be less likely to make a mistake, is we're going to rearrange the equation to solve for the unknown in terms of the known. So what does that mean? Well, I want to solve for VF, which is here. But I don't want to plug stuff in, because if I plug numbers in, I'm going to make a mistake. So I'm going to rearrange. So where do I start? Well, the goal when you do basic algebra to rearrange the equation is you have to know order of operations in math. If you don't know order of operations in math, you're going to make a mistake. So first of all, if I look at this, there's a 1/2 there. So what I'm going to do is I'm going to multiply both sides by 2. Because if I multiply both sides by 2, this is going to cancel, right? So when I do that, and I always do an arrow like this, I'll have 2x is equal to VI plus VF times T. Now there's a plus here, so I'm going to leave what's in the parentheses alone, and see that T there? So now I'm going to divide both sides by T. So now I'm going to have 2x divided by T is equal to VI plus VF. This one's a little trickier for the algebra. Okay, remember I want to solve for VF. Remember I want it all by itself in the numerator. But see how this has a plus sign? So if I want to get rid of this VI, that means I have to subtract it. So now I'm going to have 2x over t minus VI is equal to VF. So now I have my unknowns in terms of my known. Now I will substitute in my values. So 2 times 3,200 meters divided by time, which is 210 seconds, minus 6.4 meters per second is equal to VF. And you notice now it will be so easy to put in my calculator, and I won't make a mistake and get the wrong answer. So 2 times 3,200 divided by 210 minus 6.4. Now you see how this is so many decimal places? I should actually round this, let's say, to 30.5, but I'm in a hurry. So it says 24.0, so VF is equal to 24. Now, remember in physics, if I carry my units through and cancel them, so I have a meter per second here, and then I subtract a meter per second, which I can do. If this didn't come out to be meter per second, if I forgot to convert, and this would, let's say I forgot to convert, it would be kilometers per minute. Could I take a kilometer per minute and subtract a meter per second? No. So if you also carry your units through, it'll be a way, if you forget to convert, to check it. So by carrying your units through, you check your algebra, and you also check to make sure if you need to convert. So this ends up being meter per second. And that's it. Okay, now we're going to move on to D. So let's do D1. So again, for every problem, we're going to write our given, and then we're going to write our find. So D1 says a car with an initial speed of, so initial speed means VI is equal to 6.5, accelerates at a uniform rate of 0.92 meters per second squared, so I know that's the acceleration, for 3.6 seconds, so that's my time. Find the final velocity, so I want to find VF and the displacement. So I want to find two things. I want to find VF and I want to find X. Okay, so for the first part, for this part, I have VI, I have A, I have T, and I want to find VF. Those are my four variables. So I'm going to say which equation has those four. And that's the equation that we used yesterday. VF is equal to VI plus AT. So I substitute in my values. VI is 6.5 meters per second plus 0.92 meters per second squared times 3.6 seconds. So VF comes out to be, and remember, I'm going to be using these calculators on the test. So 3.6 times 0.92 equals plus 6.5 equals, so it says 9.8 meters per second. The next part says to find X. Well, what you're going to find in physics sometimes is there's more than one way to work a problem. Because in this particular case, I have VI, I have A, I have T. I want to find X. Or what if I have VI, I have T, I have X, but I already found VF? So now there's another variable in there. So sometimes there'll be more than one equation that you can use. So you can either use the answer you found in Part A or not use the answer you found in Part A. So let's look. I think most of the problems here, I could use the equation X is equal to VIT plus 1/2 AT squared. Because this way I'm not using that VF. So that's equal to VI, 6.5 meters per second, times 3.6 seconds, plus 1/2 the acceleration, 0.92 meters per second squared, times 3.6 seconds squared. So on a calculator, 3.6 squared times 0.92 divided by 2, so plus 6.5 times 3.6. I think I messed up pressing my buttons. 3.6 squared times 0.92 divided by 2. Well, this half was 5.96, and then 3.6 times 6.5 plus that comes out to be 29. So X is equal to 29 meters. Now there's another equation that's on the 4. Here it says Vf squared is equal to Vi squared plus 2Ax. So if I wanted to solve for X, do I have Vf? Well, I found that in the first part. Do I have Vi? Do I have A? So could I also solve for X this way? I can. So that's what you're going to see. Which way should you do it? Let's say on the test, the first way that you recognize it. Because most of the time our instinct is go with you and don't second guess yourself. If I had time, I could rearrange this equation and say Vf squared minus Vi squared over 2A is equal to X. And then substitute in my values. And my answer should come out to be exactly the same. That's a good way to check your work. Okay. And now on this problem, I realized I forgot to check my units. So I have here meters per second times a second plus a meter per second squared times a second squared. So this cancels with that, this cancels with that. So they're both meters. I add them together and I get meters. See how great it is to carry your units through and cancel them?